So I'm here from you again after the break. Let me remind you that we are going to consider the next bridge, the next pattern for today, that is called bridge. First of all, as usual, I would try to quickly describe the problem we have in usual object-oriented programming. The point is that the typical class, as we define it in our program, has, as you of course know, two parts, interface and implementation. The interface is the way how clients of that class communicate with instances of that class. Implementation is how this class is internally implemented. The point is, the problem is that if you declare a class derived from this one, by definition, the derived class inherits both interface and implementation of its base class. That is, in many cases, not convenient and sometimes even dangerous. Probably you remember the example with Airbus and Boeing classes in some previous lectures. When we create the derived class Boeing inherited from Airbus, the consequence, the very dangerous, of course, consequence was that Boeing started to fly using Airbus's algorithm. So in order to avoid such problems, we typically build a configuration like this. Look at the right part of the slide. Up again. Okay. So what we typically do, we declare the base class with an abstract interface implemented using pure virtual functions, as you remember. And typically it doesn't have any real implementation. This is a purely abstract class, providing the names of abstract methods that must be implemented in derived class. And we create a class derived from this abstract class that inherits interface and provides its own implementation. So for details, please refer to our example with Airbus and Boeing. Okay, let's go on. Next slide contains the illustration of this approach. Again, we declare an abstraction implemented as an abstract class in C++ or in other classes. The same feature is supported by many languages. And we provide implementation for those abstractions in a derived class. However, here we have another problem. The root of that problem, the fundamental problem here is that such relationships as inheritance is completely compile time relationship. We set up this relation at compile time, and we cannot change this kind of relation between these two classes during runtime. Well, probably the details will become clear on the next slides, but now I have to emphasize again that the relationships like inheritance is too inflexible in many real times. I should make a kind of note that pattern bridge, as it will be explained to you right now in the next slides, is very popular. Probably it is one of the most popular patterns in real programming. I must say that in many conference presentations, when a presenter shows his or her solution on the slides, he or she uses bridge pattern. So this is not an academic exercise, but a practical thing. So let's go on. So how to decouple abstraction from the implementation so that the two can vary independently. So now they are strongly connected to each other. Implementation implements abstraction, and we cannot change this thing. The idea behind bridge pattern is to decouple these two things so that they can be evolved independently. Look at the next slide. So this is the example, an abstract example of the problem. So suppose we are going to develop a portable GUI interface. And the keyword here is portable. That is, we need to ensure that our program configuration, our software, should be working, should be running on different system platforms. Here it is an example with Android and iOS. The direct way for doing that is to introduce an abstraction, for example, window. Window is a kind of basic abstraction in any GUI, and define two derived classes that contain implementation for Android and for iOS and for any other platform. Okay, this seems logical and natural, but think, one day we need to extend Windows abstraction. For example, you understand that window as it is a very high level abstraction. In reality, we need abstractions, a lower level abstractions. That is text window, icon window, and many other kinds of windows. Look at the slide. Suppose we need to provide other kinds of windows. How to update this initial hierarchy? What can we do? The only way using inheritance within the inheritance paradigm is to extend abstract window, providing a new kind of window like text window, for example. What's the consequence from this solution? The consequence is that we need at least two implementations of text window, both for Android and iOS. And the same is about each abstraction we are going to add to our hierarchy. Of course, this leads to very, very complicated, awkward hierarchy. This is, well, look at the left part of the slide. These are a couple of comments. It is very hard to promote Windows abstraction for new kinds of windows and for new platforms. Oh, this is the bug in my comment here, not platform, but platform. Okay, I will change it afterwards. And the next negative consequence is that the client code becomes platform dependent, because each time we are going to use text window, we need to mention somehow that this text window is for a particular platform. So again, this is the problem we are going to solve somehow. Look at the next slide. The overall solution to this problem is to organize two hierarchies, two class hierarchies instead of one. Probably the previous slide gives us some hint concerning this. But now let's look at this on the current slide. So the idea is to introduce two hierarchies instead of one. The one hierarchy should represent abstractions that are to be used within our software. Window, text window, icon window, etc., etc. There are a lot of abstractions in a task like this. And the separate hierarchy is the hierarchy of implementation. And a very important notice, look at the bottom line. We use delegation to set up the communication between the two. So I have already mentioned you that in many real cases, you should, and we all should, as developers, as software developers, should prefer delegation for inheritance. This is an interesting thing because it is very typically that talking about object-oriented approach, we emphasize inheritance as the very basic notion. Yes, it is. However, it is not a universal means for all cases. Okay, look at the schematic solution. So, look, we have two hierarchies. The first hierarchy is the set of abstractions. We start from the top level, very abstract window notion, and we inherit more concrete abstractions from it. Text window, icon window, and some other kinds of windows, a graphical window, or anything like that. And in parallel, we create implementations. This is an important point. Look at the topmost element of the second hierarchy, abstract window implementation. Yes, the idea of this hierarchy is implementation. However, the topmost element, topmost class, is also an abstraction. It abstracts the ways we implement things for different platforms. It abstracts them. We will see that on the real example later. And the second point, another point of this picture is real communication between these two hierarchies. Look at this wonderful red line. Abstract window has the reference, or simply speaking, pointer to abstract window implementation. And this is called the bridge. We build two hierarchies and make a bridge between these two hierarchies. This is the idea of the solution. This is just the idea, the scheme. Next, we are going to I'm going to show you the scheme of implementation of this abstract scheme. Look at the next slide. So, window, class window, that is that implements the abstraction from the previous scheme, the left topmost abstraction. Look, this is a very schematic thing. Of course, there are many details omitted, missed, but nevertheless try to catch the idea. So, class window represents the abstraction, the topmost abstraction of a window in a GUI, in some GUI. So we have very common methods in this class: open, close, and well, some other methods. Typically, there are a lot of methods, and our attention is paid on methods that should be redirected to the implementation. That are methods that depend on implementation. Methods like draw line, draw rectangle, draw text, etc. Again, there may be a lot of them. And look at the private field of that class. Reference to the implementation. The bridge I have mentioned on the previous slide. This is represented just as a pointer to some other class. Windows implementation is the, let's come back to the previous slide. This is the topmost element of the implementation hierarchy. Okay, and what is implementation? Look, so the topmost class from the right-hand hierarchy is window impl. It is abstract class. It contains a set of pure virtual functions draw line, draw rectangle, draw text, etc. They are defined as pure virtual because this is the abstraction of implementation. The real implementation comes in derived classes that represent implementation for a particular platform. On this slide, there is only one derived class, for example, for iOS implementation. And this class contains real implementations, particularly to iOS platform. So look again, there is class window. I didn't show you the class derived from window, representing text windows, icon windows, etc., because I just do not have enough space for that. However, for implementation, I have shown the base abstraction for implementation and the derived one for a particular platform. Okay, so this is the idea of how such a bridge pattern can be organized. Look at the details on that slide. This is the example of a client code that uses, this is kind of probably the most important one. We build the hierarchy, and the question is how to use that hierarchy. Look at the client code below. So the first point, the first declaration, we declare the new window. Look, we manipulate with abstraction, window, and we pass the pointer to the concrete implementation of that window. Here we say that we will have an abstraction window implemented using features from a particular platform. This line is the only point when we mention the concrete platform. The rest of the code, the only one call is shown here because of the lack of the room. The rest of code doesn't depend on a particular implementation because we use only things declared in the window class. Here is the example. We call drawLine feature, drawLine method from window class, because W declared here is the pointer to the window class, to the instance of the window class. So the rest, again, the rest of the code knows nothing about the concrete implementation. So look at a couple of comments on the right side. The client code doesn't depend on implementation details. It uses only Windows interface. This is a very important point. Client code knows nothing about the platform. It remains the same for all platforms if we use such a pattern. The second point, because these two parts are completely independent, we can evolve implementation hierarchy independently from abstract window interface. We can add new platform, we can change the implementation of methods, etc., etc. And one modification to that slide is how drawLine actually works within that hierarchy. Look, now we are going to consider how the call to drawLine from the client code is implemented internally. Look at this. So, what happens? drawLine call refers to the drawLine function from the window class. The body of that class is that we use the drawLine function from the implementation, namely from the topmost implementation class. Okay, so what is going on here? So this call goes to window implementation, to the method drawLine from the Windows implementation. However, Windows implementation is the abstract class, and the actual dynamic type of import from where we call drawLine is actually iOS window. Therefore, using the usual polymorphic paradigm, this call is redirected to the concrete iOS implementation from drawLine. So this is how the runtime system implements the client code. Of course, there are a lot of redirections, but those redirections are actually a part of object-oriented semantics, nothing else. So client code doesn't take care about these details. The effect of the call, the initial call of drawLine, is that the iOS implementation of this function gets invoked. So that's it. Probably you didn't understand all the details. I recommend you to look at this slide, to think about this slide by your own again. And this is, and another point, this is just a scheme. Many details are omitted here because of the lack of the space. But it illustrates very well, I think, very well the bridge pattern. Okay, and the last slide for today is a kind of comparison between bridge and adapter patterns. Because you probably already understand that many patterns we have considered, and many patterns we will be considering later, in some sense seem to be similar. This is also about adapter that we have already considered before, and bridge. The similarity are the following. Both promote flexibility by providing a level of indirection to another object. Look, here the illustration of indirection is visible. Both involve forwarding requests to this object from an interface other than its own. Yes, this is also the truth. However, of course, we wouldn't introduce a new bridge if it was exactly the same as one of this pattern, if it was one or was the same as one of before, considered before. There are key differences between these patterns. Adapter is to resolve incompatibilities between two existing interfaces. We have two classes that are incompatible, and we need to resolve those incompatibilities, and we use adapter for that. Whereas bridge patterns makes the bridge, well, bridges. Well, this is a kind of tautology. So anyway, bridges an abstraction and its potentially numerous implementation. So this is the way we help to keep independence between the two hierarchies. It provides a stable interface to clients because clients know only left part abstraction hierarchy, and also lets to vary the classes that implement it, because the implementation hierarchy can evolve independently, as we might see from the previous slide. And the final slide for today is an exercise. This is, again, I remind you that this is not an obligatory exercise, this is not a task, but exercises for your home thinking. The first point, suppose there are two implementations of list. You know this kind of data structure quite well. And we know, at least we intuitively feel that the list can be implemented in different ways. Probably the most direct, probably a little bit stupid implementation is to use array for representing lists. Another, a little bit more smart implementation assumes using pointers. So the idea of this exercise is that you write the two implementations of the list with the same interface and write the configuration of abstract list interface independent from the implementation and two implementations using the bridge pattern. So the configuration below looks very much like as previous one for GUI example, but it is about lists. And the next point in this exercise is to add new class that is derived from the list, that is stack. And again, build this hierarchy using the bridge pattern approach. So this is an interesting, but a little bit funny and a little bit artificial example for your home thinking. So that's it for today. Nothing else to add. I hope that this video lecture will be uploaded to Moodle probably, and you can ask questions using Moodle to me, and I will be trying to quickly give you answers if you have some questions related to this video lecture. So see you again next week. Well, unfortunately, I won't see you. However, we will meet again in the same format next week. Thank you for your attention.